All right, here we go. We're on section 1.3. We're talking about distance and we're talking about midpoints. We talked about this. We kind of talked about distance a little bit yesterday, even though we didn't use the word distance. So let me just show you what I'm talking about here. All right, let's put a number line, just a regular old number line. All right, nothing fancy, no y-axis or anything, just a straight across number line. And I always use this as an example. Let's say you're on the road. You ever travel, you see the mile markers on the road and it says what mile marker you're at. Anybody see that? Sure you do. Okay, so let's say you're going down the road and, I don't know, let's say you're at the 30 mile marker, okay? And let's say, and I don't even care about all these things in between. Let's just say down here you're at the 10. We'll make it really easy, okay? I don't even care about these marks in between. So you're at the 30 and here's the 10 right here. So let's say you're going down the road and you want to go to McDonald's, right? You're like, oh, gotta get something to eat. I'm starving, okay? And so and the sign says, okay, at the 30 mile marker, there's a McDonald's. I'm like, yeah, exit 30, you're at the McDonald's. So here I am at the 10. So this is pretty easy, all right? This is not brain surgery here. So how many miles do you have to go in order to get to McDonald's? Okay, 20 miles. And most likely, there's probably a McDonald's about every 3 miles, isn't there, on just about any road. But let's say we're out in the middle of nowhere and you got to go 20 miles to get to McDonald's. So that's what it is. So what's the math that you did here? You went what? Yeah, you went 30 minus 10. Okay, and that equals 20. You could also do this. You could have gone 10 minus 30. But what kind of answer would that give you? That'd give you a negative 20. So what they do is this. It doesn't matter what order you subtract them, but if you did this. Do you remember doing this in Algebra 1? What's that thing? Absolute value. It makes it what? It makes it positive. So it really doesn't matter what order you subtract it as long as you put it in absolute value. You follow me? Now you don't have to think of it that way. Usually I take the bigger one minus the smaller one. That's usually the easiest way to do it. That way you always get a positive number. You guys are paying attention, right? Okay, somehow I don't think that's going to be your permanent seat this marking period. See how it goes. All right, let's keep going. So if I put this in absolute value, it doesn't matter which order you subtract it, does it? As long as I make it positive. Because when we talk about distance, distance is always positive. Have you ever told somebody, okay, well, I live about negative 5 miles down the road. You ever do that? No, of course not. You always say, I live, what, 5 miles down the road. It doesn't matter which direction you're going. I could go from school to your house, that's 5 miles, or I can go from your house to the school. That's still 5 miles. There's no differentiation between positive and negative when we talk about distance, is there? Now, when you get into physics, you're going to be talking about some other things, and negatives do make a difference, but you'll worry about that when you get into physics, okay? But for right now, all our distances are always going to be positive. We good with that? All right, that's pretty simple. Let's see. Yeah, let's do another number line here, and we will put some, let's go to this. And oopsie daisy. Well, I'll just go to regular. I don't have to be real fancy. Alright, so there's a number line. I'm not going to put arrows on the end of it, but that's okay. So what if we had, that was like 5. We'll go 4, 3, 2, 1, 0, negative 1, negative 2. Alright? And what if they put some points here? Look, let's get real fancy and go a different color here. Wow, look at that. Technology is amazing, isn't it? All right, so let's put a point here. Let's put a point right here. And let's put one right here. All right, and we'll call this A, B, and C. All right, so what we have here is we've got 3 points on this number line. You know there's an infinite number of points on the number line, but I've only labeled 3 of them. So if you had a question that said, use the number line to find each measure, it'll say find... let's do this, A, B. And that's all it says. It doesn't say anything else. When you have an A, B, we talked about this yesterday, when you have an A, B, or any 2 letters next to each other, there's no little line symbol over top of it. What does that indicate? What does that mean we're trying to find here? Kathleen?
The distance between.
That's right. You're finding the distance between. Or the what? What did we say yesterday? What's that thing? Get rid of that. Okay, the length of. Remember that? The length of that line segment, or the distance between. That's exactly right. So if I wanted to find the distance between A and B, I could sit here and count, couldn't I? I can go 1, 2, 3, 4. But what if you didn't have all those little marks in there? And what if you had like real big, numbers in between? What if it was like a negative 73 and positive 84 or something like that? Then what's the math you would actually do here if you were to find this? You would take the larger number. And actually, does it matter what order you subtract them? Like here, it didn't matter if we went 30 minus 10 or 10 minus 30, did it? All right, so I could do what? I'm going to go the biggest one minus the smallest one. So let's go 2. What? It's not minus 2. What is it?
Minus negative.
Good. It's minus negative 2. And what's 2 minus negative 2? Yeah, right.
4.
It's 4, isn't it? All right, so that's the distance. And we counted it already. You could have done that. It's pretty easy. It's not brain surgery, right? It's pretty simple. So you're going the biggest one minus the smallest one. That's how you find the distance between the two. What if you wanted to find AC? What if it said find AC? What's the math that you would do? You could count the points, but let's, again, what if you had like negative 87 and positive 153? Would you want to count all those points? No, that would be ridiculous, wouldn't it? So, right, so, but let's do the math, okay? I don't want you just to, I want you to understand that, yeah, you could just count all the points, but what if you had some outrageously, long distances in between? You wouldn't want to sit there and count all those points, would you? So we got to come up with a better way of doing that, and so what would I do? I would go 5, what? Minus negative 2. And what does that give you? Positive 7. Remember I said you could go in the opposite direction? You could. It doesn't matter what order you subtract them. You could do what? Talk to me. What's another way you could come up with that?
4 plus 3. Negative 2.
Negative 2 plus?
Or
Minus. Right. You subtract. To find the distance between, you subtract. So it's negative 2 minus 5, which is what? Negative 7. You're like, well, wait a minute. 7 and negative 7, that's not the same. But distance is always what? Right, it's positive, so we stick it in the absolute value, and you get 7 either way. Isn't it a lot easier taking the bigger one minus the smaller one, though? Sure. Okay, I just want to show you, though, that you could subtract them either way as long as you make your answer positive. That's all you got to do. We good with that? All right, cool. Let's pause this for a second, and we'll draw the next little example here. All right, I'm not even going to put specific points in here. What we're going to do is we're going to find the distance of that line, but what we're going to do is we're going to actually come up with a distance formula. I'm not just going to sit here and say, okay, this is the distance formula, this is how you use it, plug the numbers in, boom, you get an answer. All right? I want to go beyond that. I want to show you where the distance formula comes from, and all that little stuff that we just talked about is really going to come into play here. So let's put a little dot right here and a little dot right here. Now, this point right here, I don't know the actual point. I didn't put any lines here, so I don't know if it's, over 3 and up 2 or over 5 and up 4. I don't know that. But I could say it's over x, put a 1. That's a 1 right there. We could go over x1 and up y1. You follow me on that? So I went over an x coordinate and I went up a y coordinate. Follow me? All right. Down here, what do you think we'll call that point down here? Right, it's got to be x2 and y2. Good. So that's x2 and y2. You okay with that? All right. Let's now do this. I want to find the distance between there. Now look, here's the x point right here on the x-axis, and here's this x point over here on the x-axis. I could find that horizontal distance, couldn't I? If I knew this point and I knew this point, what would I do to find the distance between them? What had we just been doing? Subtract them. That's right. I could subtract them. So this would actually be what? x1, because it's right under this x1. What would this be right here? This would be x2, wouldn't it? So I could find that distance. I could go, what would that distance be? It would be x1 minus x2. Good. So I could find that horizontal distance, couldn't I? Let's do the same thing with the y distances. Look at this y point right here. What would this point here be on the y-axis? You went down how far? You went down y2, didn't you? And here's the y point right here. So what would that point be? That would be y1. So what would it be from here to here? What would that distance be from y1 down to y2? Yeah, subtraction, right? y1 minus y2. You with me on this? All right, we're leading you up to something here. All right, let's go. We'll go red again. That shows up pretty good. And I'm going to try. Oh, don't do that. I'm going to go to about right there, and then I'm going to go to there. That's pretty close. Let's scooch it over just a little bit. It's not perfect, but you get the idea. All right? There we go. So what I'm going to do here is I want to find the distance, the length of this line right here, that that diagonal looking line, okay? Now look what I have. I can find this distance of this red one right here. Let's keep that red. Again, what did we say that distance was? That's the x distance. So what's that distance? It's what? x1 minus x2, correct? What's this distance up above here? It goes from y1 down to y2, so what's this distance going to be? That's right, it's going to be y1 minus y2. You with me on that? So I've got these two lengths, but you're like, well, who cares what this length is and what this length is? I'm trying to find this diagonal. What in the world does this length and this length have to do with this diagonal length? Well, it's actually got a lot to do with it. You probably learned this in Algebra 2. What do we have now? We got a triangle. You see that, don't you? Okay, what color do you want? Let's go with this green. All right, you got this triangle right here, and I've got two sides. And it's not just any old triangle. This is horizontal, this is vertical. So what kind of triangle is this?
Right triangle.
It's a right triangle. Good, so I've got a right angle there, don't I? Anything coming back to you now from Algebra 1? Yeah? Say it. Pythagorean Theorem. Very good. Okay, Pythagorean Theorem. And I can find the length of this distance right here. And that's what I'm trying to do. That's what I'm ultimately trying to do, is find the distance or the length of this line segment right here. I can do that by doing Pythagorean Theorem. All right? And what is Pythagorean Theorem? A squared plus b squared equals c squared. You got it? It doesn't matter which one the a and the b is. Let's call this one the a since that's it. X. We'll do that first. So let's write it out. Now, we are actually writing the distance formula right now. We actually came up with it on our own. All right, so let's do it. What's the a? What's this length right here? It's x1 minus x2, isn't it? But what do we do to that? We square it, don't we? Okay, and now, because I'm doing Pythagorean Theorem, this is a squared. This whole side right here is like our a for Pythagorean Theorem. This side right here is kind of like our b, and then this diagonal one we're trying to find is our c. So I'm going a squared plus b squared equals c squared. Make sense? All right. So that's our a squared plus, what's our b? What's our b? It's y1 minus y2. So it's y1 minus y2, and that thing is squared, equals, now we're not going to call it c, we'll call it d for distance. That's what we're trying to find, isn't it? We're trying to find, so instead of calling it c, that's not going to mess you up, is it? We'll call it d for distance. Or it's d what? It's a squared plus b squared equals, in this case, d squared, right? That right there is basically, I'm not going to put it in a box just yet, it's basically our distance formula, all right? But what do they do when they write this? They solve for d. If you solve for d, how do you get rid of this little 2, this little squared right here? You square it, you square root it, right? You take the square root of it. So here we go. Now we're ready to write down our distance formula. This is the distance formula. Everybody with me? Sometimes they write a capital D. That's not going to bother you, is it? If I put a capital D instead of lowercase, doesn't make any difference. So it's going to be d equals, and then what do I have to do? Take the what? Square root of both sides, right? So if I take the square root of this side, it goes away. If I take the square root of this side, it's a big old square root. And so what's inside this square root? x1 minus x2 squared plus y1 minus y2, and that's squared. Check that out. That right there is your distance formula. Okay? Looks a little complicated, but really wasn't that hard. How did you get to the distance formula? You basically just used Pythagorean Theorem, didn't you? It's just a glorified version of doing Pythagorean Theorem. But now, if I give you a point, for instance, if I give you a point, what do you think this is? Like, I don't know, 3, 2? Oops, that's a terrible 2. Let's say that point was 3, 2, and this one was what? Negative, like 5, what? Negative 1 maybe? We're just guessing. Alright, say that point right there is 3, 2, and this point was negative 5, negative 1. You don't have to draw it on a graph and connect it and all that kind of stuff. You can just plug everything into this formula right here. Does that make any sense? Yes.
You're at 14 minutes.
Oh, thank you very much. I was losing track of that. So we can actually do Pythagorean Theorem, or actually plug it into this formula, and you've got the distance. You can do that on your own. You can do that, can't you? Plug in the x's for here, put in the y's for here, and subtract them. I should show you? Alright, I'll show you in the next video. I gotta stop this though.